Hey everyone, welcome to this week's episode of AWS Show and Tell for Generative AI. My name is Rob Higuerita, and I'm a solutions architect here at AWS, and I'm joining from Austin, Texas today. And we're going to have a little bit of show here that's going to talk about some more surprise generative AI. That is the whole entire theme of the show, but we've got a little bit of show and tell, exactly as the title says, with the demo and a little bit of behind the scenes on how that demo was built. I'm joined today by Vivek and Shamika, who are going to be the stars of the show, going over a demo that they built. I'm going to let them introduce themselves because they'll do it much better than I can. So Vivek, if you want to go ahead and give us a quick introduction about yourself, and then Shamika will have you go next.
Yeah, thanks, Rob, for having us. I'm Vivek Mittal. I'm AWS Solution Architect, being here with AWS for last 3 years now, and based out of Tampa, Florida. I'm a generative AI specialist, so that's something which is near and dear to my heart. So excited to show you how we build this application. Over to you, Shamika.
It's good. Thank you. And this is Shamika Riwansa. I work as an AI/ML solutions architect focusing on healthcare and life sciences division here at AWS. I'm based out of Denver, Colorado, and I've been with AWS a little over 4 years now. And in my day-to-day work, I help organizations to um, harness the power of generative AI and build machine learning solutions on the spectrum of patient care to drug discovery.
Nice.
Me.
Cool. Yeah, so we got a little bit of everywhere as far as geography, from way far south to a little bit further north. Is it still snowing and everything, like good ski season? I have no idea what's going on in Colorado. In Texas, it's like just never know what season it is most of the time until it's just kind of randomly cold. So
yeah,
never know what's going on.
We didn't get much snow this year, surprisingly. But the ski season's still open, but the mountains are a little bit dried up. So
nice. That's cool. But interesting, not a lot of snow, but that's all right. So I guess it's okay. So yeah, like I said, it's one of those things where here we just get cold, and by cold, it's like, maybe gets down into the 30s, and that is fairly cold, but not terrible. So
yeah. Here in Florida, we are like, if it goes in 60s, then we are like, oh, it's cold today.
I know. I was there a couple weeks ago on vacation, and it was 47 degrees when I got there, and I was like, excuse me, this is not the weather I came. Was like, I mean, it was 19 here. I guess that week it was 19 in Texas. So yeah. But in any case, nobody came to hear about the weather in the US. I suppose they came to hear a little bit about what we're going to talk about. And so we're going to be going over advanced multimodal RAG assisted demo that you all built. We should probably let, for those that haven't really gotten a chance to delve into generative AI much, that are starting to get to learn a little bit with it, a little bit what multimodal means and what RAG means in general before we get into showing them how it works and such. So I'll leave it up to you all who wants to arm wrestle and choose which one wants to cover a little bit on multimodal, or maybe one of you takes multimodal and one of you takes RAG. I'll leave it up to you, but maybe share just a little bit with the audience on what those two kind of things mean and what we're going to be kind of using them for today specifically. Shamika, you talked about what your area of focus is, and I think that has a little bit to do with what we're going to be doing in the demo. So I'll let you guys introduce a little bit on what multimodal RAG and the assistant is that you guys have.
Yeah, sure. So with the generative AI applications, you would have used different applications, different chatbots, where you can drive insights from your data, right? So there are several techniques in there, like we have fine tuning, where you can use a large language model, fine tune to your particular use case, and then use it to drive insights or gain answers to your questions, right? But fine tuning generally it requires a lot of training and a lot of money along with that, right? Because it requires some large machines to do the fine tuning. So retrieval augmented generation, or RAG, is another technique that many of the businesses are using, and they are using very successfully. So the concept here is that along with your prompt or the query, you get the context as well, from your specific data source. You combine both, and then you feed it to the large language model so that it can provide you a specific answer based on your data source that you have provided. So that's the concept of RAG. Yeah.
And to give more another perspective of this one, you can ask the questions from the models today, right? So like you can directly ask the questions from the large language models. But if you come to the spectrum of medical and those kind of domains, those answers are primarily driven by the training data that it had used, and you'll easily hit the limits on that one. So one option to improve that one is, as Vivek mentioned, you can do fine tuning, but it is these are huge models, huge data sets. It's a big effort to go through. So we are settling on an intermediate step where, rather than you solely relying on the models training data, models outputs, you provide additional context to that. How do you provide that additional context is a technique called retrieval augmented generation.
Yeah. And in addition to that, you asked about multimodal, right? So we generally, the chatbots that we have, text is generally the source, right? But along with the text, you can have images as well. Or like Shamika was mentioning, if we go to healthcare, there you may have images, you may have diagrams, you may have graphs and tables, all this kind of complex data. So gaining insights from text as well as images and graphs, that is the multimodal aspect of the solution that we will be presenting today.
Yeah, I think it's a really cool aspect to it, right? Because being able to use that additional kind of data types, right? Not just saying all it is text that you can leverage for it. It's a good way to be able to augment that data, right? Yeah. So I remember the first thing that I did with using Bedrock and using anything in Generative AI was specifically doing a retrieval augmented generation. It was using the web crawler portion that we have for it. So you can add a web crawler into, I think it was Q or something like that. So you can have that as a data source. And that's kind of a neat feature because, similar to where you're just okay, I have a document source that I'm going to give, but instead it's my, website of information, and I'm going to pull that in. And now that's my more fine-tuned data, right? Instead of just going after the model, now you can take the context from what we have on a specific resource and wanted to get to. And we've got, different things within Bedrock, right, that support for this with the knowledge bases and stuff. And, but we're going to cover a little bit something different with how you're going to leverage this, right, with the different modalities to it, right? With, like you said, having images and different PDFs with charts and different stuff that are all going to be important elements to what you're trying to get back contextually for the questions you're asking, right? So you get the most that you have. So yeah, there's going to be a lot of things. It'll be interested to see, from the audience who's gotten a chance to play with some retrieval augmented generation in generative AI. What kind of use cases have you specifically gotten a chance to take a look at and see, how it's helped you to be able to, take what you have for, a Gen AI application and make it more applicable to your specific use case. So feel free to let us know in the chat if you've used a little bit of retrieval augmented generation and how you've used it, because there's always different use cases, and it's kind of interesting to hear sometimes what people end up using it for. So if you have a situation, share it in the chat and all. Yeah. Oh, also key thing, audience, if you have questions, we've got a couple experts here that you can ask about what we're going to be talking about. So as we're going through today's solution, if you've got questions about what they're talking about, feel free to ask in the chat. Let us know. We'll try and answer all the questions that we can as we're going through today. So I appreciate it. We've got some people joining from all over the place. I think it was maybe a South Africa, Brazil, Lisbon, India, Toronto, San Francisco. I'm going from countries to cities now. But moving different specificities. They said Brazil. They didn't say specifically where in Brazil. So it's a large area.
That's true.
But yeah. All right. So we've got a little demo we're going to go through, right, and show them a little bit about what you built. And then we're going to take a look at some of the architecture of it and a little bit of, kind of how to implement and stuff like that. So we should probably get into that interesting stuff and take a look at it, because I think that's probably what the audience is here to see. Although our beautiful faces are something they obviously came to see. It's probably a beautiful demo that they're more interested in. So we can go with that.
Yep. And before we jump into the demo, just Shamika, would you like to explain the use case so that it will provide a context to the viewers that what we are going to present?
Yeah,
Absolutely.
yeah. Even the concept can be applied to any other industries. I'm going to talk about the medical science space because I'm from that space. So, in the medical research, the field of medical research, new insights and the new documentations are published almost every day. These could be new drug related reports or clinical trial reports of a new drug that are being tested. On the other side of the end, so the clinical researchers and then clinical trial managers, they go through these multiple data sources which are publicly available in most of the cases, like PubMed, FDA, regulatory. They go through these things and then try to come up with their own new articles, new reports, new regulatory submissions, etc. But actually, if you look at those particular information, the bulge of information, the many critical insights are overlooked because they are buried in specialized table format, charts formats, and then graph formats, appendix, and then footnotes, etc. And a lot of images also they are buried on that. For an example, for a clinical trial, if you are writing a new clinical trial, there are Kaplan-Meier survival plots are available in there, or treatment plan charts available. In the medical research side, there are gene expression profiles and microscopic images are there. So when we want to easily research these things, you have to go through in today, you have to go through each and every of these document and get the insights out of that. But with our effort here, and then with the generative AI, emergence of generative AI, now you can have a conversation interface with these documents and then get the insights out. But one limitation that we had previously was all of these things were done through text conversations. So our effort here is, as Vivek mentioned, introduce a multimodal. So again, multimodality means we will be using to get the insights from these images, charts,
Mhm.
diagrams, etc., and then give an platform for them to do the research. So that's going to be our effort here. So with that, I'll hand it over to you, Metal.
All right. Great. Well, I'll bring up what we're going to kind of show today here
Yep.
on this assistant. Take a look at it.
So yeah, this is the advanced frag assistant that we will be demoing. And for creating this, what we have done is we got some of the research documents that Shamika was suggesting from PubMed. These are publicly available documents, and as you can see, it has different diagrams. These are related to cancer vaccination, so you can see there are some diagrams over here. Also, it's showing that how a cancer vaccination is created. Then you may have some tables also here, right? So, and along with that, you have all this text in there. So it's a pretty complex document to go through. So I have created some sample prompts. I can go through them and we can. So say we want, I have seven such documents in there in the knowledge base, right? And so say we want to create a timeline of development of mRNA vaccine technology for cancer treatment, right? So if we want to, let's see what it is. So what it will be doing, it will be going through the different chunks which are
Mhm.
created by the knowledge bases, and then it will get the data out of it. So as you can
Mhm.
see, it has browsed through all those documents, and it has created a timeline that, okay, 2017 preclinical studies demonstrated the potential of mRNA vaccination. Here you can see these are the citations. These are the chunks which it retrieved from these particular documents. And then once it opens the document, it will
Mhm.
actually open the exact document which it used, right? And then each and every aspect that it is retrieving, it is providing the corresponding citations for that as well, right?
Yeah.
Yeah.
Yeah, that's cool. So each one of those ones is kind of parsing through each one of those documents, looking at all the information that's inside of it to not just give you what it knows as far as from the model, but to say contextually, here is the specific citations within each one of those documents that you provided to it to be able to give them where they can go back and look for it, right? So they don't just have to take it at face value. Here's what the answer is. They can be like, okay, great. I'm glad you gave me as of 2024, there were numerous ongoing clinical trials, but I would like to read more detail about that because in order to actually do what they want, they need to have all the details right for it. So
Right, right.
access.
And also this improves the observability part of things also. And then people have heard about the hallucination part that the models tend to think by its own and then give the output. But we need evidence. We need evidence to prove your answer is right. So that's what these links and then these observations gives you.
Yeah, for sure. And I guess as we're going through just already, quick question that came up on the specific demo that we're sharing. Is this, RAG Assistant you're showing an app you developed, or is it something that, is it an out of the box experience from, Bedrock? So I'll ask that to you also. You can share a little bit about it. And I will go a little bit into it a little bit later, but figured it came in, so we might as well answer it while we're there.
Yeah. So this is something that we developed. There are certain out of box functionalities that are available from Amazon Bedrock knowledge bases. That's the main service that we have used to create it. But around that, we have some other applications as well that we have utilized, and we will show it how we created it when we will go through the console.
I knew that was going to be the answer, but I figured I'd ask you because the audience doesn't know the answer, right? And so we got to share the knowledge with them. That's what we're here for. And we had another comment, about the stream overall, that it's helpful even as for newer people getting to, learn different systems and things. That's what we love about our live streams, right? Like as we do these different demos, we're hopefully giving a little bit of knowledge onto how to use the different AWS services and how they can kind of be used to build out different things. And this is specifically kind of one of those situations where we've got a demo app that's built to show, what's built-in functionality into the service, but in a way that can be actually used rather than just seeing kind of what the playground that exists right within Bedrock to see what a real world kind of use case would. But
Right.
I think you brought up a really good point as well, Shamika, right? Like on the observability side of thing, like really, like you said, you can tell this is not a hallucination because here is the actual backing document that shows specifically what this is. So it's not something that it just wanted to please you and tell you that in 2024 there was numerous ongoing clinical trials. It's like, here's also my evidence that shows you that this is specifically thing. And that's kind of one of those important things we're going through with any, chat solution or any solution, and it's using generative AI is being able to improve that. Here's the actual data that's used to back it, so you can provide that as well. So
Right. And we can actually do some technical deep dive as well. For example, say we want to ask what steps are involved in the prediction of new antigen candidate for the therapeutic cancer vaccines. So we can ask that, and it can get that information, deep dive information also from the documents. So yeah, it looks at the documents, it parses the images also, it gets the insights from that as well. And that's how it is actually providing the answers. So as you see, it has provided all the main steps, right, on how you actually create the cancer predictions of cancer vaccine, right? So obtain the tumor, whole cell examination, then you run it through some algorithms, and then you select the top new antigen candidates, and then you validate that, right? And if you see the citations that are provided in the citations, it has provided this diagram as well, right, along with that. And as you can see in this diagram, this is basically what is happening. From the biopsy, it is identifying what are the tumor tissues, normal tissues. It is doing the sequencing of the RNA sequencing, and then it is running through the particular bioinformatic algorithms, and then it is used for creating the vaccination. So it is actually wonderful on how it is doing that, right? And you can actually open the document and see that, okay, this is where it is getting the information from as well.
Yeah, and that's really, because I think I'm going to pop this up here on screen because Kiefer said it best. Medical fields want precise, right? And this is exactly what you want to provide it, right? And that's kind of you point to things that you're working on, and showing in this is really giving that's very specific, like, here's your precise bit of information, because yeah, we're dealing with medical stuff, right? We want to make sure that it is actually, that.
Yep,
So,
yep. And other question that we are generally getting from the customer is they want to compare the different vaccinations, right? The efficacies of different vaccination. So we tried these things as well, like compare the efficacy and safety profiles for these two vaccines, right? So if you ask this question, it will actually try to get the data, and then it will provide a nice comparison of these two different vaccines as well. So that is also another powerful use case that R&D teams are generally using while using this RAG applications. Yep.
Nice.
And one point that those diagrams, I see some of the comments also. The diagrams, it's not only getting the footnote of that diagram; it tries to interpret that diagram to the knowledge of ML model also. So in that previous example, it tries to get that human, and then that vaccine process. It tries to interpret, and also that uses as a reference that that rightly pointing to the right document.
And a question along that, right? Pointing to the right documents, and I think are all these docs vectorized? It might be helpful for those again that are just tuning in and learning a little bit about generative AI, what that means. But also, we can answer, I guess, Chris' question there as well.
So for all these documents, and we will go through it during our demo, means we will show how typically RAG works. But in general, when you have two phases, ingestion phase, and then you have the retrieval phase. So during the ingestion phase, the documents are actually divided into chunks, and then these chunks are stored as embeddings in the vector database. And these embeddings are stored so that the words which are words, or these embeddings which are semantically similar to each other, are near to each other, so that when you are asking the question, it is getting the context based from that vector database very quickly, and that context is semantically correct, right? And that context is then added to the query and fed to the LLM so that you get the proper answer. So that is the full flow, and we will go more detail in that as well.
Yeah, it's kind of interesting when you're going to get into that a little bit later, like how that all works, because it's kind of you start to kind of learn and like see how it's not. I mean, it's looking at the images, right, and it's looking at the data, but it's not like looking at it as we would with our eyes if we were going to search through and scan things, right? Just kind of the way that it. Otherwise, it would take forever, right? If you imagine your eyes going through and having to read that document by itself and interpret what the actual graphs were representing, and what the different, like, just even like the equations and things like that go into it, right? That you're like, it would take you a minute to like understand it. And it does it so much faster because it knows exactly how to contextually align, optimize, and put it in a way where when you ask it, it's like, no, here you go. Here's your answer. Like I did that in a matter of, not even seconds, right? To give you that in some cases. So very cool.
Right. And like this question, compare the efficacy and safety profiles of vaccines based on MAG A3 or NY-ESO1. So it provided the comparison, right, on these two different type of vaccines, and along with that, it again provided all the citations that are required for that. So it is first providing regarding MAG A3 vaccines on what are the efficacies related to that, and then it is so as you see here, it is actually getting the information from the tables as well. So and it is getting the context out of it and putting it there. Same way here, you see another table is there. So all these are the different chunks which are stored in the vector database, and based on the relevance of these chunks, it is getting all the answers from there.
Mm-hmm.
Yep. Okay.
Yeah.
So with that, let's actually dive deep into more
How
into
this all works.
on how RAG actually works.
Yeah.
So So as I was saying, there are two flows in retrieval augmented generation. One is data ingestion flow. So in the data ingestion flow, you have all these documents, right? Text, and it can even be the images as well. And then it is fed to the embeddings model, and from the embeddings model, it is stored in the vector store, where
Mhm.
these embeddings are stored in there, which are semantically similar. Then after that, you have the text generation flow as well. And in the text generation flow, what happens is user first asks the question from, and user's question is actually converted into the embeddings as well. And then it searches from the documents, it adds the context, and user's query is added along with the context. This is the prompt augmentation, and then it is fed to the large language model. And based on that, it is providing you the response. So the response is very directed to the user query, to your actual data. So this is how RAG works in general. But
Mhm.
in here, because here you see it's just the text documents, right? And we wanted to see how we can actually drive insights from the documents which have images and graphs and
Vivek.
tables as well. Yeah.
Yeah, Vivek, before you go there, like, shall we explain what is an embedding and what is the
Yeah, yeah.
how is yeah. So uh, primarily these documents, if the documents are huge, what we do is we call it we chunk the documents, right?
Mhm.
So we cut the documents into few pieces, and then we convert those segments of the document into a vector, that is set of numerical numbers. Why we are converting that one to numerical numbers is, if you want to search that one, what are the similar document chunks, it is easy to do with the vectors than you compare that one with the text.
Yeah.
So one other important thing about this, when we are converting that one to vectors, is each similar sentences should come as a similar vector similarity score. So that's why we use embedding model here. It'll preserve the similarity, the semantic similarity of the different document phrases. Okay, so using that technique, we convert that one to a vectors, and then all the vectors, or each chunk has its own representation vector. We are storing that one in the vector store. Okay, and from the user's question also, now that's another set of a text, right? So we convert that one to also go through an embedding, and then convert that one to a vector. Now we have a query vector, and all the vectors of the document, it's just like doing a quick match of that one. And using that, you'll get the most matching contexts, few contexts on that, and that is the one you're passing into the large language model to get the answer, right? So as I mentioned earlier, now we are not solely relying on the large language model. Now we are providing additional context using our vector store to improve the accuracy and then see the observability of the answers that we are getting.
Yep, yep. Thanks, Shweta. Thanks for adding that context. So, yeah, and as I was explaining earlier, these are the text documents, right? But we wanted to add the images as well on top of that. So for that, there are certain new features which have been introduced in Amazon Bedrock knowledge bases, which we will be utilizing. But in general, as you see, if you have the multimodal data, you need to extract that multimodal data, and then you need to interpret that multimodal data as well. So what is happening here is we are actually using a large language model here, which is a multimodal large language model, and these documents are first passed through that large language model, and that large language model is creating uh, uh, means is interpreting that data, and then that data is converted into the embeddings and stored in the vector store. So if there is an image, for example, so that image, say it's an image of a dog,
Mhm.
the dog is happy running around, right? So the large language model will interpret that image and create the text out of it, and then store that text as the vector embeddings in the vector store. And once that is done, then the user's query is also converted into the embeddings, like Shamika was explaining earlier. A match is found, and once the match is found, it will provide that context added to the user query. And then other thing that is happening here is whatever images are extracted from the original source document, those images are also stored in a bucket or in a storage, right? And along with that context, this all these chunks have the linked images as well. So when the user is asking the question, along with the answer in the text, it is also retrieving the linked images over there. So that's how we were able to show the images as well in the citation.
Yeah, that's cool. Yeah, that little bit of extra bit of information. It's kind of funny you mentioned like using a dog, because when I was mentioned before we kind of went live, that I was trying to explain a little bit to my wife, who is not in tech at all, about how it kind of worked, what we're talking about today. And I used a dog as an example, mostly because she was holding my little Chihuahua at the time, and it was like, like it wouldn't be a picture of a dog that you're actually looking at. It's all data that makes up that dog. She was like, okay. She's like, that's cool, but it's interesting to hear, because it's so many different things, right, that it goes and does for different things. So we did have a couple questions come in as you're going through some of that. So I'm going to pop a couple of them up here to ask. They're kind of just general things about what we've been talking about, and kind of some of the retrieving of items and whatnot as well. But one of them came in from one of our users on YouTube that's currently watching, and they wanted to know, are tokens vectorized for the entire question? Kind of wondering a little bit on, how tokenization works for, when you're retrieving things, what the cost is there. So got that one. And then I got another one after that as well before I move on, but I will let you answer one question at a time.
Typically, these questions are, if you see compared to the document chunks, the questions are shorter, right? So you will typically ask, compare these two vaccines and all. So it's safe to say entire tokens. So what are tokens? We split these entire text into something called tokens. It's a little shorter than words. It has a multiple. It can be having a single word, can be multiple tokens also. So entire token is converted into a vector that is called embedding. But your question is valid. Some of the embedding models have limitations of how many tokens that it can accept. So let's say in this case, I think we have used around like a 1.5k token limit for the embedding. So our chunking size also, we tend to keep it within matching with that fund. So then we'll get the maximum accuracy on that. So you have to understand what is the limitations of your embedding model, and then attune your right chunking strategy according to that.
Makes sense. And I'm going to throw this one. I was going to ask another question. I might go back to that one. I want to throw this one up because it's like one of these, like your mileage may vary questions, right? Like, well, it depends. I don't know if there's a right answer for this one specifically, because one single solution. So I'll just put it up here. Heidi asked, which AWS database service should we use for the storage of vector store? I think that's mildly a loaded question, right? Because it depends. But I'll let you answer, because you all are the experts, not me.
So can I? Okay. So there are multiple options available. So the vector stores, the native databases that AWS provide, most of them now support vector store also. Like for example, RDS or Aurora, they have the vector storing capability. Right?
PG vector, I think, yeah.
PG vector, like that. And also there are purposely built specialized databases within the Bedrock also that you can directly store the vector store. So recommendation is, if you can leverage existing databases and then leverage the existing vector capability on that front, that is a less hassle for you. You don't have to worry about new licensing. You don't have to worry about new adapting to a new platform, etc. So try to leverage that as much as possible. If you are building a new use case, which is a native RAG, which having a documents that you want to pass through, then you can go to Bedrock natively supporting knowledge bases on that. So it's a journey, I would say.
That's why I thought I'd pop it up. It was like, it's a great question because there's several different ways, like several different answers for it, right? Like it kind of depends. But but yeah, well, there is a lot of really great questions that are coming in. I'm going to let you all continue through for a little bit here because I want to make sure you get through all the content that you do want to share, because I know there's a little bit more here. But we'll probably go back and I'll try and pull a few of the questions that we have coming in. But please keep the questions coming, audience. We appreciate them, and we'll try and get to them. And I apologize if we don't get to them all today as we go through. But I'll let you continue going through what you're covering here and these, and then we've got a little bit more in the console, I think, coming up too.
Cool. Thank you. Here I just want to show you how we are using Bedrock knowledge bases, as because it provides a managed service, managed retrieval augmented generation. So all the different advanced parsing techniques and the smart advanced chunking techniques that we use, multimodal retrieval that we used, are being supported by knowledge bases. We talked about smart parsing using foundation model. We talked about multimodal retrieval. I don't think we talked about the advanced chunking. So this is another capability that we have in knowledge bases. So in knowledge bases, we have fixed chunking strategy which is supported. But in addition to that, we do have the semantic chunking and a hierarchical chunking also supported. With semantic chunking, it actually tries to get the meaning of the phrase, and then based on that it creates the chunk and the chunk sizes. And with the hierarchical chunking, it actually takes into account the relationship between the child and the parent as well. So say if you have a table, if you have a table of content, then it will try to keep the parent and the child relationship along with that as well. So different, depending on the different use cases, different chunking techniques might work better for one versus other. Yeah. And yeah.
One highlight I want to make here is if you go to the previous slide, Vivek. So
Yeah.
yeah, so you see a lot of pieces here, a lot of pieces that you need to uh, glue them together, right? So with the Bedrock knowledge bases, they'll take care of that, this entire structure. That's why we call it manage retrieval augmented solution. So all these components now, it is embedded within the knowledge base, and Vivek will show in the AWS console how do you glue them together. It's just like within the clicks you can glue them together and then create this solution.
Right, right. Thanks for pointing that out, Shamika. So yeah, with the managed solution, you won't have to build it from scratch, right? Building the vector database, building a different ingestion foundation model, and then putting on together all these things. It takes time and it takes a lot of effort. So we'll show you how you can easily build that. It's not that difficult. With knowledge bases, they have made it very easy. So let me dive into the console. So here I'm on AWS console. I'm on Amazon Bedrock. I hope it is visible to everyone.
Yep. Yeah, we can see it.
Okay, nice. So over here, you see we have all the different features which are supported by Bedrock are listed over here. And if we go to builder tools and knowledge bases, so here you can go to create. Here you have different options. You can create with a vector store. You can even have a structured data store where you can ask in natural language and it can get the data from your structured data store as well. You can even use Canvas and index, uh, which is another service which is helping with getting the data. So we will go with the vector store for now. So with vector store, you provide any name to the knowledge base. You can ask it to create its service role itself, or you can use existing service role. And the data source, as you can see, there are different data sources which are supported. Uh, for this solution, we used Amazon S3, which is object storage service, where you can store your PDF documents or images or even the Word documents. You can even use web crawler, where you can provide the website address and it will crawl for you. Uh, Confluence is another third-party data source which has been recently added along with Salesforce and SharePoint. So these are all the different data sources which are supported, and you have the custom data source as well, where you can use APIs to ingest the documents directly into the knowledge bases. So that is also something which has been added in reInvent last year. So once you have selected your data source, you go and you select your S3 bucket or whatever was your data source. So since I selected S3 as the data source, I can browse, select my S3 data, bucket. Uh, and then once I have the S3 bucket selected, here we have the parsing strategy that I was talking about earlier. This is the ingestion phase, right? So in the ingestion phase, you can use Amazon Bedrock default parser. You can use foundational model as a parser as well. This is what we used for this particular solution. And here you have the choice of different models like Claude 3.5 and Claude 3 Haiku.
Yeah.
Uh, we have selected Claude 3 Haiku, and then you have here the chunking strategy.
Right. So this is that previous setting is, if I'm not mistaken, that's the one doing the interpretation, right?
Yes.
Yeah. So when the image is seen, the Bedrock platform, knowledge based platform, will forward that image to one of these models that you selected, and it gets an interpretation on that. Yeah.
Right, right. And once you select that, here are the different chunking strategies that we were talking about that you can select from here. So for this particular use case, we use the semantic chunking. We were not getting that good of results with default chunking. So we use semantic chunking, and it actually helped us in providing much better answers and much better accuracy. Yeah. Uh,
In doing this, like by choosing that, like you've got the max token size for chunk and different things. So like we had some questions and comments, things about like understanding how those work and like breaking those up to, avoid hitting limits and things like that for different models. This is one way where you could help to do that. Looks like to say, hey, chunk this up into specific things so we can get the max token size within a specific window for the model if we need to, with all the different chunking methods and things. Is that right?
Right, right, right. Yeah. So here we can actually change the size of the chunks as well, to make sure that the embedding model that we are using it is as per that as well.
Yeah. One more point on that is like, if you open up the semantic chunking, there are default strategies like, it is cut off by 1,000 characters, so thousand. That's where when you see that, we don't get much of the accuracy on that one. What semantic chunking does is it will go scan through the document, and then closest sentences within the document, one by one, they put them together. So one chunk would be like a heading in that case, other chunk would be like entire next paragraph, because those are linked together. And to further configure that one, you have these three parameters: token size for a chunk, and then breakpoints, like what are the different breakpoints that you need to threshold. Like, so if everything is 95 and above, they'll come as a together chunk, like that. So yeah.
Yep, yep. And once you select that, there are some other functionalities also available. You can actually use your own custom chunking using a Lambda function. That functionality is also there, so that also you can do it. We will leave it at this for now. And there is this other thing that you can actually provide instructions to the parser that, okay, this is how I want the chunking, this is how I want it. And so you can actually provide instructions to the large language model, which is parsing. So this can be provided here as well. Yeah.
Okay. Real quick question before you move on from there. Just because you were asked, you mentioned that you had the default that didn't really give you the greatest context or like the different greatest answers back, right? Kumar from LinkedIn watching wanted to know, is there a way to check what chunking strategy will work good for a specific use case, or is it more of a trial and error approach, when you're kind of going through that? Sounds like you had to give a little bit of trial and error, but I didn't know if there's any specific recommendations, that typically work in this case you had to do a little trial and error. But figured I'd just probe there on that one.
This field is also very evolving. Initially, we used to use the default chunking strategy, like cut off by specific points. But now I would say good starting points would be semantic chunking, and then hierarchical chunking, and other one is agentic chunking, which is we don't support that one here. But these three, semantic and hierarchical chunking, would be the best option. But again, this is a cost trade-off also, because if you're using semantic chunking, you'll be using another large language model. Your entire documents will be sent it to the large language model, so it will incur some of the cost. So start with a very simple one, and then go to the most common ways, like start with the default chunking, go to the hierarchical chunking, and then go to the semantic chunking, and then see how your accuracy is improved within that. So having a test set and then having accuracy measurement is really important in that case. So it is a trial and error with the selective set of strategies.
Makes sense. Yeah. A little trial and error, a little bit of this should be your best choice, especially like you said, cost, right? Want to make sure that you're doing everything with the cost in mind and not jump to straight to, what might be the most potentially accurate, but also the least cost friendly when you could get what you need from maybe a slightly cheaper option. So that would be a good thing to keep
Right.
in mind.
Right. And yeah, cost is another, yeah, that's a good call out, to make sure that you are keeping cost also in mind, right? Uh, so once you select your data source, you select your chunking strategy, foundational model parsing, you select the embedding model, right? So you have here Amazon embedding model supported, and then there are certain models from Cohere as well. So for our use case, we use the Titan Text Embedding V2. This is the latest one that we have. And then in the additional configuration, we have to select the embedding type as well. With floating point vector embeddings, it provides a more precise vector representation of text. So that provided us much better results. And now, once you have selected that, you have to select your vector database, right? And like Shamika was saying earlier, we have different options in here. So you can actually select from one of these data sources like Amazon Aurora, or you can even use Pinecone or MongoDB Atlas. Neptune GraphReg is also supported, and that is for those use cases where you want to maintain the relationship between different nodes. So that's where you use GraphReg as well. So these are the different vector stores which are available. By default, it goes with Amazon OpenSearch Serverless. So that's what we used. And once we use that, here is the multimodal storage destination. So this is the bucket where um, the images which are extracted from the original source document will be stored, and these will be actually linked to the chunks which are getting stored in your vector db, so that when the user will retrieve the information, the corresponding citation with the image will also be showed to the user, right? So here you can select your multimodal storage destination as any S3 bucket, and it will when you will sync your data store, at the time it will actually create the images out of it. And once you select that, you review and you create the knowledge base, and it takes some time, like 5-10 minutes, and then it will be created, right? And I already have one of the knowledge bases created, so I will show that to you. So this is how it looks like once it is created, right? You will have the knowledge base id, and here it will
Mhm.
list you the different data stores that are there. So you have the data store name, and you have the S3 bucket where all these documents are selected. It shows you the semantic chunking, the parsing strategy that you selected,
Mhm.
and then it has the multimodal storage destination as well. So this is how it will look like, and it provide you an interface where, yeah.
Follow up question on that: what happen if a new document added to that S3 location?
Right. So what happens is, once you have actually stored your document, you have created your knowledge base, right? So you have to first sync your data store. So when you will sync your data store, what will happen is, this is the ingestion phase start, right? So it will start the foundational model parsing. It will create the embeddings, and it will store in the vector database. Now, suppose there is a new document which has been stored in a S3 bucket. So there are few ways with knowledge bases. It provides you the APIs so that you can trigger the sync again as soon as your document has been added to the S3 bucket, right? So it can automatically trigger the sync process, or you can come manually and do it from here as well if you are just testing it out. So you can do that as well. Yeah. So that's a good
Yep.
question. And other than that, you can this it provides a interface where you can test it with different models. And here you have different options, right? Like
Mhm.
it has to so what it does is, when you are retrieving it, it first retrieves it, and then it sends it to the foundation model. So if you remove this generate responses, so it will just provide you what it is retrieving. So whatever chunks are being retrieved from the vector database, that will be shown here. But if you retrieve and generate, then it will actually feed it to the foundation model as well, and then generate the responses. So here you can specify the number of source chunks which will be retrieved. If you increase the number of source chunks, it generally provides better results, but then it again comes at the um, um, with some more cost and some more time as well, because it has to process the different source chunks. But because more context is coming, then it may
Hmm.
provide better results. You have filters as well, where you can provide the filters based on the metadata that it is creating. So say you have different documents, so you can associate metadata with the documents, and then you can filter based on those metadata, saying that, okay, I want to extract information from this particular document. So if a metadata is associated with it, you can filter with that. And then you can attach guardrails. What are guardrails? Guardrails is another item where you can uh, actually safeguard your RAG application um, from hallucination, from different items like uh, you want to make sure there is no sexual content or no harmful content in there.
Right.
So all these things, responsible AI related items, you can set up using the guardrails.
Yep. Yep. Guardrails are important, right? They're very helpful. Very nice thing that Bedrock offers that can be useful for a lot of things. But yeah.
Yep, yep. And then here you have different models, right? You can play around with. For example, you can choose Nova Pro. You can ask here the question, and then it will actually provide you similar answer, like we were seeing just now. For example, say we want to ask this question, create a timeline, right? So you can play around with the different models that we have. Like say we selected Nova Pro here, and you can ask the question, and you can see maybe just to compare the responses of the different item and different models which are there, right? So like here
Yeah.
it's providing based on the retrieve results, these are the different timings. It starts from 2017 all the way to 2024.
Yeah.
Yeah, yeah. And
Yeah.
here also you can see the citations. These are the different citations which are there, and you can see the details of it as well. So it will show you the different source chunks from
Oh,
where it is getting information. Yeah.
nice. Nice. Yeah. Yeah. That's all really helpful and great information to be able to see, right? A lot of the details and things behind it. We've had a lot of comments and different questions and things from the audience. I don't think we're gonna have time to get to them, unfortunately, today, because there are some really great questions there. That maybe we can get a chance to respond on LinkedIn afterwards, because there's a lot about context and being able to provide different things in order to better conceptualize things, to different performance strategies with leveraging retrieval augmented generation. And does it add latency to things? Does it improve performance? How do we do different things for a lot of a variety of different comments? But what I will say before we wrap up for the evening tonight and stuff, everything, we do have a couple different resources, right, to share as well that people can go through and look at. And I will paste those into the chat, because I think earlier on in the conversation, I saw someone post one blog about it, but we've got some different samples, right? Like there's a Git repo that you have that's got some of the different information
Yep.
that's helpful. There's blog contests go around it. So I'm going to paste this into the chat so everyone can take a chance to look at the GitHub resources that you have here as well. Is there anything key that you want to hit on in the repos before we end up having to wrap for today that's important for people to take a look at as they go through? Because I'll also share the blogs as well. But just any kind of key items that you want to cover?
Yeah, so in the GitHub repo, you will see the whole solution. It actually has the infrastructure as code as well. So you can deploy the solution, right? And it has all the steps so that you can actually create this same solution, and you can try it out with your own documents, right? It has the whole architecture and everything. So please do try it out. And we are happy to see people experimenting with their own documents and provide the comments on how the solution is.
Yeah, that's key. Go take a chance to take it for a spin, right? See how it works for them in their different use cases and everything, because that'll be really great to be able to see some pulls and stuff from the repo and have them implement and test it out. So any last key bits of wisdom or anything like that you want to kind of highlight last minute here? Again, for the audience, appreciate all of the questions and such so far. Hopefully you've enjoyed today's episode, but Vivek and Shamika, I'll just see any last parting moments or parting gifts for the audience of knowledge.
Yeah, just one more item I would like to highlight would be we discussed about the trade-offs between the price, performance, and the cost, right? So there are different resources available. This is one of the blogs, and Rob will send it out to you. So this is a great read. Go through it so that you can see the trade-offs for your reg application, how you can actually productionize it when you are moving from POC to production. There are several other resources also available, like this one is specifically for analysis and discovery of cancer biomarkers with Bedrock agents. So go look out on that, specifically if there are any healthcare, life science, or biotech related audience over here. So this will be very helpful resource for them.
Great. Yeah. A lot of good reading there for them to be able to take a look at. And there's, I'm sure, some more. And I think, there were some questions that will be answered by being able to take a look at that blog as well. So for the audience that had some of the questions, that I think if you take a look through here, you'll find a few answers. So I know we didn't get to them today, and specifically being able to ask Vivek and Shamika about them, but take a look through the blog resources and the Git repo that we shared. It'll give you some additional data on specific things so that you can take a look at that. So the link should be in the chat for each one of, I have them posted on where we stream everywhere, which is all over on Facebook, Twitch, LinkedIn, and YouTube. So take a look at the links. You should see them posted for me. But otherwise, I think that's all we have for today. I appreciate your time, Vivek and Shamika, for coming on and sharing this solution with everyone and being able to give a little bit of the information on Bedrock and using kind of the retrieval augmented generation for that advanced multimodal usage for the different medical information. I think it was really cool to be able to see all the details and kind of how it pulled from those different sources and showed the diagrams and everything.
Thank you for having
pictures going along. So
thanks, Rob. Thanks a lot for having us.
All right. Well, thanks, audience, for joining. Have a great night, and we'll see you again next week on same time, same place.
Thank you.